fire up your neurons. What's up, nerds? The Sangenator here with tales from the digital crypt, tales of creation, connection, collaboration to inspire, uplift, and educate. How often have you had to repeat a trip to the grocery store to pick up that one item you forgot? Lists are helpful, but only if you remember to keep your lists up to date. Sounds like a job for an app, doesn't it? Especially one enabled with artificial intelligence. I have just a thing for you. And the app I have created is called Annapurnayai, or Anna for short. As you consume items like this bottle of ghee, take a snap of the package before you discard it. Anna will detect the item and add it to a running list. Then during your trip to the grocery store, just use the simple visual interface to strike items off the list as you pick them up at the store. Launch the app by clicking on the icon like any other app on the Android phone. Anna has two screens, Plan and Prepare, where we add items to the shopping cart, and Purchase for the trip to the grocery store. In Plan and Purchase, step 1, use the Acquire button to take a snap of the discarded item. Anna will show the snap in the window by the button when ready. Step 2. Next, click on the Analyze button so Anna can detect the item. Anna will read the label, detect the item, and report the result. Here, Anna has detected that the discarded item is a box of ghee or clarified butter. Yummy. Tea is always on the list because we can never run out of tea. You can also edit the list if required. Step 3. Finally, add the item to the shopping cart. At any time, you can switch between adding items and viewing the shopping cart. Ghee has now been added to the shopping cart along with other items that were there already. During the trip to the grocery store, keep striking items off the list as you find them. Just tap on an item. This pulls up more details about the item, such as the preferred brand, etc. You have the option to keep it or strike it off the list. I created Anna using a technology platform called the App Inventor from MIT. The App Inventor is a wonderful platform for makers. It is not only a great way to learn coding by building Android apps, but an amazing way to learn about technologies like artificial intelligence, Internet of Things, and the cloud that are changing our world. Let's dive in. The number crunching involved in artificial intelligence is substantial. It is way beyond the limited storage capacity and computational abilities of this smartphone. Also, the App Inventor has limited or no support for artificial intelligence and machine learning. So Anna has 3 friends to help her do the heavy lifting. Would you like to meet these 3 amigos? Let's do it. These 3 amigos are web services. Imagine having access to the unlimited storage at Dropbox or the virtually unlimited computational power of Google's data centers. You can do that with web services. Anna uses three: Dropbox to give us a folder in the cloud to host our Snap. Google Cloud Vision gives us access to deep learning in the cloud for computer vision, and Redis gives us memory in the cloud for the shopping cart. How to use a web service? A service has two components: a request part and a response part. Like this chick demanding a pizza from her boyfriend, a request is initiated by a client. In our case, the smartphone app. It is a message telling the server to create, retrieve, update, or delete information. When all goes well, the dude grants her wish and the pizza is delivered. The server responds with status 200, which is a code for success. Off the happy path, though, the dude is unable to satisfy his chick, and he better have a good reason why, or find another girlfriend. The server responds with an error code, different from 200, often 401. The request message is encoded in the URL, like www.google.com is a URL, via query parameters, or it may be contained in the body of the request. Headers have metadata about the request, such as a description of the contents of the body. Documents shipped over the web, like cat's pictures, are contained in the body of the request or response. Yes, like the request, the response has a body and headers. In the case of web services, the information contained in the response body is structured using a format called JSON, or JavaScript Serialized Object Notation. The emergence of JSON as a standard has made web services very, very popular as a way to share information on the web. In App Inventor, actions performed by the app's user, like clicking on a button, are events that trigger execution of a part of the program called a callback. Anna listens for button clicks to initiate requests to various services. When the app receives the response, thus completing a request response cycle, that is an event of another kind, and a return message is processed in the callback. The whole app is a series of request response cycles, one after the other. Anna orchestrates the sequence to get the job done in a step by step manner. Normally, as an app's developer, you will be writing line after line of code. For an Android app, that would be Java code in a programming language called Java. With App Inventor, also you are coding. And the experience is like playing with a box of Legos. Everything that you need in a programming language is made available to you as Lego blocks that you put together to develop your program. But don't be fooled. These blocks are nothing but wrappers around Java code. What this does is it abstracts away all of the detail so the app's developer can focus on what a block does and how to put blocks together into a program rather than being bogged down by the detail. This produces a super intuitive experience and lowers the barrier to entry to code. Let's take a look at the code behind Anna. To access App Inventor, go to the website ai2.appinventor.mit.edu. All the action happens here. There is nothing to download or install to get coding. The App Inventor has two views. The designer is where you craft the look and feel of your app. The blocks view is where you code the functionality. You can switch between these two views at any time. To build your program, you drag and drop components from the designer's palette that the app's user will see on the screen. The drawer called User Interface has components like buttons, text boxes, text labels, etc. The Media drawer has components like camera, audio and video recorders, and players. Modern day smartphones have an array of sensors like the accelerometer, GPS sensor, compass, etc. Find these in the sensors drawer to incorporate into your project. There are drawers with components for storage, to access databases on the device and in the cloud, connectivity, Bluetooth, Wi-Fi, even social media. Keep everything organized with layouts in the layout drawer. As we drag and drop components to build out the shell of the app, components appear in the panel on right in a hierarchy. The properties panel is where we specify the initial attributes of a component. These attributes can later be modified in our code. Blocks is where we build out the functionality of our app in code. We drag and drop blocks to build our program. App Inventor supports data structures like lists, dictionaries, to represent data appropriately in our program. Flow control, if-else statements, for loops, while loops, to control what part of the program runs when. The math and logic drawers help us build out our algorithm. To keep our code well organized, we can use variables and procedures, which are functions. Finally, App Inventor is based on an event-driven pattern, where an event, such as the click of a button, triggers execution of a part of the program called callback. Let's see this in action. Anna uses the Dropbox service to store the images we acquire. The click event of the acquire button triggers a callback, wherein the camera on the device takes a picture. The after picture event then triggers the callback by which the snap is posted to Dropbox. The meaty part of the app is the got text event, where the response is handled. The Dropbox API responds with status 200 when all goes well, and a name and a number ID of the posted image. We then make a follow-up request using the name to get a shareable link. With a tiny bit of tidying, the link is ready to use. Here's what that looks like for the image that we just posted to Dropbox. We are now ready to send this image to a computer vision service for object detection. The computer vision service I have used in Anna is from Google. In another video, I will go into alternatives to Google and how they compare. For now, we'll stick with Google. The click event of the Analyze button triggers the callback, wherein the image is sent to Google Cloud Vision. The service uses deep learning to read the label and sends us back the information. As before, the meaty part of the code is the got text event, where the response is handled. The Google Cloud Vision service responds with status 200 when all goes well and furnishes all of the recognizable text in the image label. With a teensy bit of tidying and a little bit of luck, we get a match. Anna then shows this information to the user. Finally, Anna listens for the Add to Cart button click to put new items on the shopping list. Anna uses Redis, a database service hosted by MIT in their cloud. My wife and I both use the app, so by using Redis, we see the same information, no matter who is using the app and on what device. Over the last 10 to 15 minutes, I've given you a taste of App Inventor. You have seen some of the native capabilities of App Inventor and how this can be extended with web services. The possibilities are limitless. From apps to stay on top of to-do lists, to navigational apps with geospatial maps and GPS sensing, to growing your own food with a little help from an app to manage and monitor your home garden. If you can imagine it, you can build it with App Inventor. And this is not a toy. The apps that you build are fully functioning products that you can put on the App Store and share with friends. There's never been a better time to channel your inner nerd. And App Inventor is a wonderful tool to go about it. I've included some links in the description below so we can geek out together. What are you waiting for? Jump right in. Thank you and see you soon.